Hello, let's play a Fillomino. This one's called Cubicles by Fikes. So I sourced this from GM Puzzles. Let's go over the rules. So what we need to do is we need to draw regions in the grid. I'm going to call those ominoes because it's Fillominos anyway, because like we have a pentomino here would be 5 in size. Anyway, we're just drawing them. We need to fill, every single cell needs to be part of an omino. So we're just dividing it into regions. Now, there's a couple rules here. One is that any of our given digits must be in an omino of that size. Now, you can see here that this is a valid 4, by the way. This is a valid 5. We can fill this with a 4 as well to remind ourselves. But the whole point is that this is an omino of size 4, and the 4s go in it. This is an omino of size 5. The 5s go in it. Now, we are allowed to draw just a region that... Like this is a 4 cell size. It doesn't have a given in it. That's fine. Every single cell is going to end up in an omino just by the fact that we're dividing into regions. And additionally, ominos of the same size are not allowed to touch. So this would be disallowed. We have a 4. Oopsie. We have a 4 and a 4 touching each other here. That is no good. That's the other rule. So, we could make this a 5. And they can touch diagonally. They just can't touch. So like we could do, pretend that 3 and 2 aren't there. We could do a 4 and 4 like that. But they just can't touch. They can't share edges. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so what's our in? Well, I mean, we can draw the borders between non-matching givens, which can actually be helpful here. Now, just because the givens match doesn't mean they're in the same. But here, this 4 needs to escape. So we know this is going to be a 4. Now, if it connected up here, we'd have too many 4s, right? That we can do that logic because 4s aren't allowed to be next to 4s. And so we're not going up here. So this is a barrier. And so now the 4 has to grow to here. So that's a barrier. Or just a line. Anyway, there's a line there. The 6 has to get out. It's got to go here, and then out one more. Oh, that barrier is not there. Now this 5, I mean, the 6 could come up here. It just can't come up all 2. So the 6, okay, so this could be a 6, but we can't do this because now the 5 is trapped. So we could go up, but even if we went up, we'd still only be 5 in size. So we still have to come over to here. So that's a line. I don't know what to call them. Edge. Maybe that's an edge. Now, the 6 either continues to here, and we'd have an edge here, or it goes up, and we'd have an edge in a few places. Anyway, so it's not done yet. This needs to be part of an omino. Now, it doesn't have to grab the 7, though. We could do an omino of like size 3 and just be done with it. So we can't do that logic. Let's see. Are there any other forced moves? This can't be a 4 because that's 5 of them. So, oh, what just happened? Okay. So we can't go this way. And this can't go this way. So this 4 is going to get out this way. I don't know which way it goes from there. 1, 2, 3, 4, 5, 6, 7. So if these were both 7, we'd have a completed region, and that would work okay. These 7s probably connect. No, these 7s do connect. Sorry, they do connect because they're next to each other. So I don't really have any way to draw that, but we need 3 more 7s somewhere. This 2 either goes down or left and then finishes. I believe we can have 1s as islands. So I can't say something like if this 2 goes down, that's a 7, because it could be a 1. Let's see here. So what's this doing? What number is it? I guess it could be a 5. It could just be doing its own thing, like a 1 or a 2. Oh, right. This can't be a 4. So we have this barrier as well, since that can't be a 4. We don't know that this escapes because it could just be a 1. And the thing that keeps you from making everything 1s is you can't have 1s next to each other. But also these givens have to be correct. Is it viable for this 3 to go up? I don't think it is. Right. So this 4 region could grow 1 over to here. This would be viable-ish. Right, there's not an immediate problem, but we wouldn't be able to grow further. We can't grow into this 4, and we can't go down here next to this 4. So even if we took 1 more, we still have to go 1 more to the right. So that's a barrier. Now the 3 has to escape here. So that's a I guess I'm calling them barriers. I want to call them edges. So the 4 either goes here or here. Oh, this 3 can't go down because it would join this 3. Okay. So that's our 3, and then that 3 is done. I guess I don't need that. I like it with the top. Okay. This could just be a 2. It doesn't necessarily mean the 7 takes these 2. This 4 has to grow here, and now it's done. Okay. So I was dubious if that worked. The only way it works is if we do that, and then now this is a 1. Okay, what's next? I want 5 to just take these 2, but I don't think I can prove right now that that happens. This 3 can't go here. It will be next to a 3, so it's going to have to go down. It needs 1 more. It's not going to be here. Now, if I put a 3 here, this 7 only gets 5 cells, so that's no good. So the 3 takes this one. This could be a 1 or a 7. I don't know which. 1, 2, 3. Yeah. So I said that this could be a 7-omino. Is that septomino? I don't actually know. So I can't say that the 7 takes these 2. But even if the 7 did take these 2 up here, what am I doing? If the 7 took these 2, we still only have 5 7s. So we still need to grow down 2 more, and then now it connects to this one. Oh, that's cool. Okay. So we have our 7-omino. That makes this a 2. Because you can't put a 1 and a 1 next to each other. That's kind of what I was trying to say earlier. I think this has to be a 1. No, it could be like a 3. We could do like 3, 3, 3. Okay. We still don't know what the 6 is doing. What else can we do? This 3 doesn't go up, so it's going to have to come out here. This one doesn't go up either. So yeah, it's got to finish there. Now the 2 has to go down. That's a 2, that's a 1. All right, let's draw those lines. Oh, we should finish the 2. Finish the 4 and the 1 and this 4. I don't know, I kind of like that. Maybe I should just green the whole. I'll just green everything there. Okay. So we could put a 1 here, but ooh, interesting. Oh, the 7 could come down. I'm thinking about the contention here. This can't be a 2. This needs to be 2 different regions. Or be grabbed by the 7 maybe. But what I can't, okay, 1, 2, 3, 4, 5. What I can't do is 6 and 1. No, I could do 6 and 1, sorry. What I can't do is 2 and 2, because it'll be next to a 2. That's the only thing I can't do. But this could be a 6 or a 7. This could be 6, 7, or 1. I don't know. This could be a 1 even. No, then I'll make this 1. So this can't be 1. I think this is 6 or 7 then. This is 6 or 7. I don't want to do that. What are we doing then? Well, even if the 5 took these 2, it still now has to escape up here. And that finishes that. Now the 4 is done. And that makes this a 1. So I'm glad I didn't make the 5 grab it. This 5 has to come out. This could still be a 1. But even if this was... Okay. So even if this was a 5, we still need 1 more. So we'd either be... We could... If this was a 5, we couldn't grow here. We'd have to grow here. Why did I mark this as... Oh, because the 5 comes out. Right. So I should have made that 5 as well. Now this could be a 6 or a 5. The 5 would finish us. So what we can't do is make this a 5, because now we've got way too many 5s, right? I didn't have this other 5 in for some reason when I was doing that other analysis. So this definitely doesn't go down. So even if we take all 4 of these, this has to grow to this 5. So now this can't be a 5 here. So it's got to be a 1. This, no matter what, these aren't connecting. So yeah, this is a 5. Okay. This is a 6. I do not have instincts for this game. I think every instinct I've had has been wrong so far. This 7's going to have to get out. Even if whether or not it takes this one, it's coming out. And that does make this a 5, not a 1. So 1, 2, and it's going to get out again, and it's going to connect to these 7s. And that actually makes this a 7. So we're going to draw that border there. And then we got the 1, and the 2, and we're done. Hooray! All right. Nice. Fillomino is a really fun pencil puzzle. I think it's one of those long-standing ones that you can play a ton of. So anyway, how'd you do?